Hello and welcome to C# 101, an introduction. This is class number 2 for our Good Monday students. Welcome everyone. So we're up and running now. We've done a little bit of discussion beforehand. I should have had recording going on just a second ago to let those of you that were not able to catch this class, but you watch the video later on tonight, know that this coming Wednesday, so if today's March 5th, it'll be March the 7th, at 3 p.m., so the same time that this Monday class has started. So again, we're GMT minus 6, but that's 3 p.m. Central Time for us. We will be holding an open office hours webinar session for those of you in the C# class. Nelson and I will just be hanging out here for 1 to 2 hours. And during that time, you are welcome to join into the webinar. The details will be posted inside the member sponsor lounge, but we're going to be here making ourselves available to answer questions and look at your screens if you're having any trouble with getting code to compile and execute. Basically, we're making ourselves available for you. Looking over at BuzzNet right now, questions come in from Mr. Toots, if that's how you say it. This is going to be recorded, right? I guess I can if you'd like for me to. It's not going to be your standard class type thing. It's almost going to be, you can almost think of it like just a kickback radio time. All right, Toots, just for you, it'll be recorded. So we'll record it and we'll make some sort of entry up, I guess, in the calendar system so that you guys can see what was going on. So let's see. Outside of that, Nelson, let's go ahead and start with a review from what was covered this past week. Quite a few different things. After we go through the review, then I want to spend just a few minutes taking a look at homework from a perspective of, well, Nelson doing it. But quick review. First thing we talked about last week was the IDE, the Integrated Development Environment, and how we are using Visual Studio 2010. You can see right now Nelson is modeling this for you, this sexy software on his screen. That's right. You can see he's just kind of moving the mouse around. That's quite an attractive piece of software. Much, much better than working in a text editor, something like Notepad, which is no longer sexy. Though Notepad++ is a bit sexier, it's still missing all of the features that we get from Visual Studio 2010. So you should be working in 2010. Projects and solutions, if you recall, we did discuss projects and solutions, kind of lying at the very heart of the stuff that you're creating. Go ahead, Nelson. Talk about it for a second.
Yeah, so Visual Studio basically organizes the stuff, your workspace, I guess you could say, by solutions. And a solution is going to be a collection of projects, and a project is going to be a collection of code files. So the main unit that you use with Visual Studio is going to always be a solution. Visual Studio can only have one solution open at a time. Underneath the solution, over here, like in our Solution Explorer, you'll see we do have a project underneath the solution. This project corresponds to a program or reusable code library that's going to be built by Visual Studio. Underneath the project, we have the individual code files that make up the executable code for this project.
Simple enough. So just keep that in mind. One solution within the solution, multiple projects can exist. Right now, we're just doing very simple applications, and you're not going to be using multiple projects at this time, and most likely not throughout this entire 101 class, though in the future it is something that you will see. And for those of you that are following along with us in the more advanced C# classes that we're doing, not really classes, but things like the MMO class, Nelson's Corner, etc., you've probably gotten quite comfortable seeing us work with multiple projects inside of a solution. All right, so from there we wrote a very simple application. As you can see right now, Nelson has fired up a new console application, and he just deleted everything out. Real quickly, he's throwing it back in there. So it was very, very simple. It was just writing out to the console, hello world, or hey in this case, as Nelson has updated. And then we were calling upon read key so that we held up program execution until the user pressed any key on their keyboard, and then the program terminated. Once we all got this up, We talked for just a minute about, the code has to be compiled in order for it to be executed on our machine. And we spent just a few minutes talking about the difference between native versus managed code. And of course, we are working in a managed environment, working within the .NET framework. Talking about managed code being the final code being compiled out so that it is, the CPU understands it. But the code that gets compiled out here inside of C# is not code that our processor can understand. Instead, we need a runtime, an execution environment that is capable of taking this intermediate code, IL code, and basically compile it to the final state for machine language for the CPU to understand. But we spent a little bit of time talking about that, which brought us over into a little discussion about the .NET framework. And if we were to take the .NET framework and just boil it all the way down to just 3 statements, we could say that it's nothing more than a managed language compilers, an execution environment, which we told you guys was the CLR, the Common Language Runtime, and finally, the BCL, or the base class libraries. And Nelson's just thrown up some comments for you guys as well. So we talked about these different things from a very high level point of view. And then from there, we took this little simple program that we wrote, and we jumped into a discussion on C# syntax fundamentals, with the very first thing that we talked about being every single program that we write has to have an entry point. The CLR needs to know where execution is going to kick off at within our application, and the typical place is main, and Nelson has that highlighted right now. Main is a method. You guys are going to learn how to work with methods as we progress forward in the 101 class, and a method is nothing more than a block of code that is designed to do a specific task. In this case, main's method, its primary function is, well, the entry point for your entire application. We also talked about things like keywords. So these are reserved words for the C# language itself, and Nelson's highlighting some of them right now: static, void, class, using. You guys also worked with if statements. You saw ints, strings. We saw a lot of different keywords in the last class, and I'm sure that you've worked with several of them yourself over the completion of your homework. From there, we talked about comments, and again, Nelson is using some single-line comments right there. I don't believe we really spent as much time in our Monday class talking about comments as we did in the Thursday night class, but Nelson is demonstrating a multi-line comment, and then he's also demonstrating documentation. And we didn't really spend any time on documentation, I know that for sure, but documentation is... this type of a comment, if you will, is really designed for tools that can go through, take a look at your code, at all of the documentation that you've set up, and basically extract it and put together real documentation for you. It's very cool stuff. So moving on from there, we talked about simple statements and how simple statements end with terminators, and we can see simple statements on both lines 10 and 11, and we can see the terminator, which is a semicolon, being highlighted at the end there. But we did say that not all statements end with a terminator, as we know if statements do not, and we'll see later on today while statements as well. So there, Nelson just gave you a quick example of an if statement. No terminator at the end. So we also talked about white space and formatting and the importance of it, meaning no formatting, and life becomes quite miserable for us quickly, and it will become miserable for you as well when you go back and look at your code later on, and if everything is just left aligned, shudder. Naming conventions, we talked a little bit about that, but that'll become much more important to you as we start taking a closer look at the kinds of members that we can set up within our types, and we'll make sure to point out what the casing should be. We also talked about methods, and I went over that just a second ago. We talked about types a little bit, and types lay at the very heart of C# programming. Everything's a type. It's all C# programming is all about creating, declaring, and using types. the end. It's that simple. Between lines 10 and 12, Nelson has put together a few variable declarations for you using types. Line 10, an integer type, which will hold whole numbers for us, both positive and negative. Line 11, a string type, which will hold alphanumeric, or just characters, symbols as well. And then finally, a Boolean type, which will hold true or false. Not 1 or 0, but an actual true or an actual false. And then finally, we talked about namespaces. And with namespaces, we basically pointed out how it was really just a way to do a logical grouping of types. And so Nelson is demonstrating a namespace right now, system, which we are using up above on line 1. But we can see inside of system that we have classes that we can take advantage of. And there are also other namespaces as well that we can take advantage of. So namespaces can be put together in a hierarchical fashion. So again, it's just a logical way of us grouping related class types together or related types together. From there, we gave an introduction to variables, which Nelson has already once again kind of reviewed up on the screen right now with the 3 types that we had created, which was integers, strings, and bools. But we saw when creating variables, it was nothing more than having to declare it first, which required us first specifying a type and then specifying an identifier. And Nelson has separated both the declaration of the number variable of type integer from the initializer, where we're actually taking the number and initializing it to 10, number being the identifier for our integer variable. We talked a little bit about the rules, and I won't go back over all of that just to try to hurry this up, but we talked about the rules for naming our identifiers. We also talked about the importance of making sure that your identifier needs to be something that makes sense for how you are using it. That's very important. You wouldn't want to go in there and just say int YYU equals and then some crazy expression or something, because it's going to be like, what does YYU even mean? It really should be something that is descriptive for what and how that particular variable is being used. So finally, after going over our introduction to variables, the last thing we did was we took a look at if statements. And with if statements, we had the ability to let our program become intelligent, to make decisions. And so right now, Nelson is demonstrating how we're always going to do a console write line, true is true, and I assume he's going to say false, or this is, okay, never happens. Good enough. It comes down to, in the if statement itself, up on line 16, the expression that's in there evaluating to true to execute the code that follows. Otherwise, the else, which is optional, doing whatever needs to be done if the expression evaluates to false. So there's a quick 13-minute review of the things that we talked about. At this point, Nelson, let's go ahead and spend just a minute and code up the homework.
Alrighty.
Oh, Gavin, yes.
I did, in fact, I sent it to everyone because I hadn't set the right, I don't know my way around the thing yet. But, yeah, the deadline for this week's homework is tomorrow.
Okay. And for those of you that happen to be watching right now and you have not done homework, I mean, I would try to tune out for a moment, because I do want to review for those of you that finish the homework. You'll only be hurting yourself if you watch it now and then try it. Try actually doing the homework based off of what you saw in the class last week. So trust me, that would be much better for you. But anyways, go ahead, Nelson.
Alrighty, so I'm going to go ahead and nuke all this code. And, okay, so the program starts off with asking you, or, well, welcoming you. And then asking you for how much money you have. Then it's going to take in the input of whatever you specify and store it in some sort of variable. And in this case, I'm going to be using the int.parse method. Then it's going to give you a list of options for items that you could pick. So we can go ahead and say something like console.writeLine, please select an item. And then we can go ahead and write out stuff like 1 cope, $3, and so on. So really, really simple. I'm just coding this at the most straightforward way possible, given what we taught in the lesson before. I realize that some of you guys actually went beyond that. So, yeah. And then it's going to get your choice. So I'm going to go ahead and say int menu selection equals int parse console read line. And then we can do a bunch of if statements to determine wow, I'm going to butcher that word, validity of their choice, and then beyond that, what they can actually do with it. So we can go ahead and say if menu selection is smaller than 1. Oh, I wish we went over ORs, Jason. I just realized.
That's okay, though. I know that.
Okay,
Remember, we wanted to kick things off nice and simple for our true beginners.
Also, I should probably add curlies.
Yes, you should.
Okay, so at that point we say invalid selection. Then I'm going to go ahead and say if menu selection is a 1, then console.writeLine, you purchased Coke for $3, and then I'm going to say current balance equals current balance minus 3. And then I'm just going to go on and do the other menu selections. So we have 1, 2, 3, 4. And one of the great things about this example in particular is there's so much repetitive code that we can make no longer repetitive as we, learn more tools within the C# language. That's kind of why I like this example in particular. So that's going to be 52, 20, and 10. 52, 52, 20, and 10. And then, yeah, don't repeat yourself. Yeah, I'm repeating myself quite a bit. Console.writeLine, you have dollars left. So this is the simplest way. It is missing one feature, and I can't remember if that feature was marked as optional or not, and that is checking your balance. Do you remember if that was an optional or?
Well, we were having people go ahead and scroll back down. Hey, Gavin, unmute yourself and come in real quick. Or I'll help you. There you are, Gavin.
Yeah, no, you muted me. No, it was compulsory to check that they had enough money to buy what they were trying to buy. What was optional was giving them multiple chances.
Okay.
Yeah, I know. On this end of the house, I asked the two girls that were working on this, Suzanne and Meta, to make sure that you could actually afford the selection that you wanted to purchase, and they were both, having never programmed before, able to work it out.
Okay, so I'm going to go do string selected item name and int selected item price. I'm actually going to go ahead and, okay, so then instead of doing a console.writeLine, I'm just going to say selected item name equals Coke. And then selected item price equals 3. 52, and then it is kind of painful to write code this way. I just want to point that up. Okay, so what is this going to be? Mountain Dew's, what, 20, was it? That's expensive Mountain Dew. Okay, so then now we have that, and then I can go ahead and say something like selected item, or then I'm going to say bool selected item, or did select item equals false. Selected item name, I'm going to give these default values. Then I'm going to actually nuke that entirely, and I'm going to say did select item equals true. And so now at the end of this program, we have all of the information that we need in order to perform an operation or show an error message if we need to. So what I can do is I can say if not did select item, then console.writeLine, you entered an invalid choice. And then I can say else if selected item price is greater than current balance, then I can go ahead and say console WriteLine, you cannot afford a selected item name. And then finally I can say else WriteLine, you purchased a $4 and then I can finally say current balance minus equals selected item price.
Just go ahead and say current balance equals current balance minus.
Oh, sorry. Alrighty.
Now, your code, I just saw where Wendy had said over in BuzzNet that I may have failed as my code was different than this. No. If you accomplished what we needed to accomplish, I know over here that the way the two girls did it here was that inside of if their selected item was 1 or 2 or 3, within each of those, they then basically said if, and then their current money that they had minus the money that was for the cost of the item, minus that was less than 0, then they would just console write out you can't afford it. Else, then they would say that this is what you just bought. They just repeated that all the way down, and that was fine. That worked just fine. And that's exactly how Wendy did it as well. Very cool. So yeah, don't think, oh dear heavens, I did it. There's so many different ways to do things inside of code. So many different ways. So this is just one approach that Nelson is demonstrating. Now, what if you used a switch statement? And if you used a switch statement, that's absolutely fine. We didn't teach them, so it obviously was not a requirement. Wow, that was close. Wipes brow. It's okay, Wendy. It's all good. Okay, so any questions? Please do not feel shy to ask questions. Steve Jones did ask Nelson. He says the requirement specified the greater than symbol before the input value.
That wasn't the intention of what I said, and I must have been not clear about it. What I meant was in the example output of the program, I was specifying my input with the greater than symbol, not that the greater than symbol was required. However, it'd probably look nicer if it was there in the first place. But
yeah,
in that particular case, I was just saying, if you see the line start off with the greater than symbol, this isn't what the program outputs. This is what the user typed in. But it's okay if you put it there because it would look better anyway.
Absolutely.
Nelson, did you see what the webinar chat?
Yes. Webinar chat? Oh. Oh. I know how to program.
There's another one.
Really? There. Okay.
All right. Now you want to test it?
Yeah. Let's say I have $100 and I buy some Hunter, and I purchased a Hunter for $10, and I have $90 left. And then if I were to say that I had $10, but then I tried to purchase this overpriced Mountain Dew, it would say you cannot afford a Mountain Dew.
Cool.
But yeah, this is probably close to the shortest you could have made this with what we went over. I'm guessing, with the exception of these right lines, which you could put all in the same line if you wanted to.
Mm-hmm.
But yeah.
I mean, again, are there any questions about what Nelson has done or that you've done? And again, if you think it's something that could be a longer-winded question, again, you can also ask it on Wednesday when we just have open office hours. So your call, but I do want to throw the opportunity out there before we move forward. Okay, well, it doesn't look like we've got... wait a minute.
We do have one question.
Yeah, go ahead.
Although, could you please put questions inside of the questionnaire in BuzzNet or on the webinar? Because I'm not looking at the chat 100% of the time, so I might miss questions if they come in through there. I got a question asked, what does this symbol mean? This is the not operator. The not operator is a unary operator, which means that it is applied to a single value, as opposed to a binary operator, this is a binary operator because it takes in two values. Same with the addition operator, that's a binary operator. This is a unary operator that only takes in one value, and it's only applicable to Booleans, and it'll take whatever the Boolean is and flip it. So if did select item was true, then this if statement would not execute. If did select item is false, then it would execute. And then NATO asked, how did I think like this? And one of the things that I did see some of the homework. One of the things that is you start to kind of realize as you continue is separating out different responsibilities of different things. So you'll see right here, we don't do any console input or output. All this is pure logic. And then what it does is it takes the input, provides a bunch of values that it's going to operate on as it does its computation. It'll perform its computation, and then at the end, the program will take the result of that computation and actually provide output for it. And that's a very common pattern that'll allow you to separate out a bunch of redundant console write line methods, and indeed a bunch of redundant logic. Because like Jason said, there are people who repeat this logic multiple times. But what you see here is because we've taken the operation of choosing a menu item, identifying the name and identifying the price, and we've abstracted that away from console input and done it all just inside of code right here, which gives us the flexibility to use those values only one time to perform these final computations. So that's, like I said, it's a very common pattern and a very good way to think about a lot of different problems. Without using loops, how would you implement retries, go-to statements, or recursion? See, I did. That's another funny thing. Someone said you did not check to see if you ordered something that was not on the menu. You'll notice that I set my did select item here to false. And this did select item only becomes true if one of these items were matched. So down here, I can say if did select item was never set to true, that means none of these if statements were executed, which means they did not enter a valid choice.
And that was allowed to get, that enabled you to get your code out that you had originally written, saying that if it was less than 1 or greater than 4.
So even further, let us cut down on the code and just perform the operation operation of computing the values or performing output of the values in one single place. Wait a sec, bad Nelson? What did I do?
Maybe because you mentioned go-tos?
Oh, yeah. I've thought about posting the code If I do post this code, it will be after the Thursday class has submitted their homework. I mean, unless Jason and Gav have a different idea.
No, it would be after, and that's even then. I mean, you can go back and watch this video and hit pause and type it out along with him, which I would recommend that over just going back and reviewing someone else's code because it's more practice. And the more practice you get, if you are a complete beginner, the better. So, okay, so any other actual questions? All right, just looking over, and I'm not seeing any actual new questions, which is good. So
this code only goes through once, that's correct. It doesn't do any sort of stuff. So that makes it loop.
Okay, so today, the things that we're going to be taking a look at, thank you very much, Nelson. We're going to be looking at just a few more variable types, or I can start saying data types. We've looked at ints and we've looked at strings. This week we were supposed to add to that floats, decimals, and booleans, but it's kind of funny because we've already looked at bools, though we can talk about them again. Then Nelson's going to go over some conversions. We're going to talk about explicit casting, implicit casting, and then no conversion. So basically a type conversion without casting, where we use things like parse, TryParse, etc. From there, I did have on the original outline, we were going to go over the concept of null and void. But to be honest, I would like to wait just a little bit longer until we get into types and methods, classes and methods, which I think is going to be coming up next week. Or at least methods will be coming up next week. And then kind of the heavy things for today begins. We'll be talking about arrays, what they are, declaring, creating, and assigning arrays, using them, using some of the methods that are available on arrays. There are definitely easier ways that we can go about dealing with collections of data, but everybody that's new to programming really needs to understand the base concept of an array. And then from there, we're going to go over into looping, and we're going to take a look at the while loop. Now, there are several different ways that we can go about looping, but the while loop is very simple, so we'll be focusing on that particular one today. So with that, again, well, let me throw this in real fast. And that is, everybody use your webinar real quick. Find where the hand is. So where you can like raise your hand. See if you can find that for me. And man, talk about, I'm going to drag this window to the other side because it just keeps wanting to attach. Everybody click the hand. Click the hand. Man, what is that? There we go. That's better. Come on, now if you don't click the hand, I know you're not paying attention. Click the hand. It's getting better, getting better. Most of you, good, good, good. All right, here's what I want to do. When Nelson has you follow along with something, I want everybody that's following along, when they start, to click on their hand. Let's not worry about using the participating thing today. There's another issue that I have yet to tell Nelson about. And we'll be talking about that later on after class today. But this is a way that both people with BuzzNet and without BuzzNet can let us know. So right now, everybody, well, most everybody, Jen, has their hands up. That's better. JT, what's wrong, man? Steve. All right, so watch this. Let's pretend you're following along with something that Nelson's doing, and you just finished. Put your hand down, indicating that you're done. Let's see how fast they go down. Down, faster, faster. Come on. Oh, Joseph, don't get confused. You took it down, then you put it back up. All right, and you're leaving it up. All right, there you go. Good deal. So now everybody, with the exception of Vern, has put their hands down. This will be a very easy way to let us know that you don't need any extra time and you're ready to go forward. This way, it'll work for everyone. So that's what we're going to do. So don't worry about ready checks, Nelson. Let's just do it like this, and we have nothing to worry about as far as people that are not running BuzzNet letting us know that they're following. Okay? And with that, Nella, let's see. You want me to look at my webinar chat? All right, give me 1 second. But Nelson, let's go ahead and start. I'll hand it back over to you. Start talking about floats and decimal and Yeah, those are two of the big ones for today.
I'm just going to go ahead and nuke. Well, I will. Just to get the basic thing that we've been using up till this point. Okay, so floats and decimals and, I mean, what about the other one?
Well, everything that needed to be reviewed or gone back over is going to be integer, float, decimal, boolean, and strings. If you want it, and we've already covered several of them, if you want to introduce one or two more, feel free. Just remember your true beginners that are sitting out there right now that are shy to say anything. And then you have people like Segfault saying, you know, bad Nelly and repeating code and things that might confuse your complete beginner. So the complete beginner are the people we really want to make sure that we're addressing right now.
Okay. So, first of all, I did go over this in the Thursday class, but I don't think I went over it in the Monday class. Int. This is a C#. Whoa. That was weird. This is a C# keyword that literally translates into this. So I just wanted to point that out, that every single one of these types that you'll see actually exist inside of system. They're part of the BCL, and they're available between all .NET languages. The reason we can use the word int without specifying system is because this is a magical C# keyword that'll just expand into this. And there's a corresponding type in system for every one of these keywords. I just wanted to point that out, that int's nothing magical or special as far as the C# compiler is concerned, because all it will do is simply replace it with system.in32 when it actually goes to run or compile. So we've looked at ints. Ints contain numbers, whole numbers. We've looked at strings. Strings contain text. Alphanumeric, anything, well, really any text, honestly, anything that can be encoded in UTF-8 is here. So that includes special symbols, symbols from other languages and stuff like that. That's all built into C# for understanding text. We've talked about bools. A bool is just either going to be true or false. So these are kind of what we've talked about already, but there still is a large amount of things that we have or that we would want to store data in that we can't represent with these three simple types. What we're going to look at are floats, double, decimal, and yeah, I think that's it for now, actually. Mm-hmm. And the funny thing is all of these three types use the same or can store the same kinds of underlying data. And that data is going to be numbers that have a decimal point. So if you look on line 7, if I try to say 10.5, what I'll get is a compiler error because I cannot, 10.5 is a value that cannot be stored into an integer data type. Integers do not understand decimal points. However, I could do that with a float if I wanted to. Well, let's do it actually just with a double. And I'll talk about why that is in a second. So we can do that with a double. We can go ahead and do 10.5. And what the reason is because floats, doubles, and decimals are what are called floating point data types, which that means that they're capable of understanding the decimal point. The difference between these three types is the amount of precision that they have. A float has the least amount of precision. It is capable of storing the least amount of decimal places, but it also consumes less memory. Double, like the name implies, is going to go ahead and store twice as much data as a float can, and is twice as precise. A decimal is going to be a 128-bit type that's going to support even more precision for doing things. Decimal is usually often the preferred choice when dealing with money situation, when you can get down to incredibly small levels of money. So, I mean, is everybody good with that so far?
Questions. And I did see the question from a couple of people saying that hands down means done, and that is correct. When we get rolling in just a minute with you guys following along, it'll just be simply put your hand up when you are following and then put it back down when you are caught up. So right now a few hands have gone up, so I take it that those of you are typing out what Nelson is doing right now. And if you have what he's typed out, put your hand down. Wow, it's like fireworks over here. Hands are going up, down, up, down, up, down, down, up, down, down. Whoa, ah! All right, Meta's behind me giggling. So for those of you that are trying to screw with me, come on, let's use it seriously, if possible.
Yes, I said decimals are often used with money.
And don't worry, Toots, when we're actually, when we're having you guys actually do something, I will make sure to say, go ahead and put your hands up.
Do you need all that much precision for money? The IRS is going to say so.
Yep. And so would banks.
Yep.
As a matter of fact, without the precision, that's an interesting way to lose millions of dollars.
That's also an interesting way to get sued.
That's true. Okay, so if you've got your hand up, we're going to go ahead and go on with the discussion. So you can put it down. But go ahead, Nelson.
All right, I did want to point out. Should I talk about literals for a second? Because you'll notice that if I try to assign a float to 10.5, I'll get an error, even though you. Okay, so in the C# language, we have what are called literals, and this 10.5 is a literal, false is a literal, this string is a literal, and this 10 is a literal. Those are, well, literally, literal values that you type into your program, and the C# compiler interprets as a value, determines what type that value is, and then that literal becomes that type. And it might be confusing at first, but if you think about it, everything in C# needs to have a type. I cannot assign an int to anything that doesn't have a type, because then how would an int understand how to take the data from whatever you're assigning it to and put it into its memory location. So everything has a type in C#, and that includes literal statements.
Go ahead and up your font size real quick as well.
Okay.
There you go.
Okay, so in C#, you will have system.int32 is going to be the literal type for just whole numbers. The C# compiler will treat these literals as whole numbers, as system.int32s. It's going to treat these as system.strings, these as system.booleans. It's going to treat these statements, 10.5, which is technically something that a float can store. But here's the interesting thing. This literal is actually a system.double. So if you try to say a float equals 10.5, you will actually get a compiler error. Because although you can put a float into a double implicitly, you cannot put a double into a float, because a double is going to require twice as much storage space in order to work properly. So we'll see that literal of type double cannot be implicitly converted to type float. Use the F suffix to create a literal of this type. So the C# compiler is actually jumping ahead for a second, but I just wanted to point out that the reason why this does not compile and won't compile is because this is a literal value. Its type is system.double. System.double cannot be stuffed into a float by default. So then what do? We tell the C# compiler to treat this literal as a float by using the F suffix. This is a very, very, very common problem, and I've seen people just give up on using floats entirely because they don't understand why they can't stuff 10.5 into a float. But the reason is, like I said, because the C# compiler treats this as a double literal, and you have to specify to the C# compiler that you want this instead to be a float value or a single value. Decimals also have their own literals. So with this decimal, you'll see that we cannot stick a double into a decimal. However, what we can do is we can use the M suffix to specify that this literal is going to be treated as a decimal instead of a float or a double. So again, when working with these three types, which all more or less do the exact same thing with different amounts of precision. You have to remember the F suffix for floats, no suffix for doubles, and the M suffix for decimals. That sounds purposefully confusing. Yeah, it is. There is a reason why it is like this. However, that being said, the C# compiler could have been created in such a way that you wouldn't have to specify these suffixes, but it's something that you have to be aware of when you're working with these three types. All right, I'm going to look over at questions.
Okay.
What about decimal equals a decimal decimal? Okay, so someone's asking, what about this? This is going to probably result in the exact same output, but this is using explicit casting, which we're going to get to a little bit later. Just for, like I said, this is probably going to result in the exact same compiler output, but this is cleaner and looks nicer and is shorter. But we'll talk about the explicit casting here shortly. Why is the double the standard for not having a suffix? I don't know. ask Microsoft. Is there a difference in F versus F literal suffix for the float? I never used a capital F, but it looks like it works. So, no, there's no difference.
Yeah, judging by their help, it would have to work. But yeah, I've never used a capital F either.
So if I only have this float, then it'll automatically be treated as a double. If you have a float, if you have this will result in a compiler error because this is treated as a double, and a double cannot be assigned to a float. F I get, but M, maybe it's for money. I don't know. Da-da-da. Not sure the difference between float and decimal. Float, double, and decimal all can store the same kinds of values. Now remember, an int can only store whole numbers, a string can only store text, a boolean can only store true or false, but floats, doubles, and decimals all store floating point values. The difference between these three is the amount of precision that they have. If I were to stick a sufficiently large number into this float, I would lose precision and that data would become rounded. Same thing with double. If I were to stick a sufficient amount of data into this double, eventually that data would become not correct. Same with decimal though, but decimal is a lot harder to do because it stores quite a bit more data than the other one. Why can't we store a double into a decimal? Decimal reserves enough memory. That's either going to be something that the C# team did based off of, well, semantics. They didn't want people to be throwing data types around and requiring conversions all the time. Alternatively, it could be because of the internal storage mechanism between these three types. Despite the fact that they work very similarly, it's going to be using the, I can't remember the standard right now. There's an actual ISO standard for how this all works if you want to look it up and read about it, but I'll remember sometime. But I mean, I can't answer that definitively, but all I can say is that's how it works.
Okay, so
Are the F and M the only prefixes to values that you'll be using? Yes. There might be a D. Yeah, there is a D, but there's no reason to use a D.
So I was going to say, let's go ahead and move on from here, Nelson, and let's start talking about conversions with explicit and implicit casting.
Okay, so in the C# language, there's actually a lot of very complex rules about how certain types of data can be converted into other types of data. And there's going to always be there's always going to be three states when talking about taking a type of data, let's say an integer, and converting it into another type of data, let's say a string. There's going to be three states that it's going to fall into. Either the conversion is going to happen implicitly, or the conversion is going to happen explicitly, or the conversion is simply not going to happen through the mechanism of the C# language, and instead you have to do things manually. So an example of an implicit conversion would be probably converting the simplest one, converting an integer into a float. This is an implicit conversion right here. Remember, all literals have types in C#. The C# compiler isn't going to look for the context of where this literal appears in. Instead, it's going to literally see this is just an integer, it's a whole number, and we're going to treat it as a system.in32. So what I'm showing here is that this system.in32 is implicitly assignable to this float because there's an implicit conversion between an int and a float. However, if I try to assign an int to or a float to an int, I'll get an error. There is not an implicit conversion between the two. But what I could do if I wanted to is use the explicit conversion to change the data type for me. Now, as a rule of thumb, think about it this way. With the exception of obviously floats, doubles, and decimals, but in most cases, the way I like thinking about it is, if this contains information that is going to be lost during the conversion process, it's probably going to require an explicit conversion. So this explicit conversion here, this casting of this float value into this integer value, we are losing data. We are losing this 0.5. So we have to say, yes, we are sure that we want to lose that data, and we are sure that we just want the integer part out of this float, or in this case, double, sorry, and that stored into the integer. So are there any questions? And it doesn't round it? No, it will not round it. Yeah, like segfault says, it truncates, meaning it literally chops this value off. So any questions about this so far? Or everyone good?
Now, I don't know if you saw, I mean, it's up in the chat area, but can you give an example of why you'd want to do that?
I mean, not one that wouldn't require a bunch of setup to kind of explain. I mean, yeah, there will be times where you'll have, for example, a mathematical library that only operates on floats or doubles. But then you want to take the result of that mathematical computation and use it to position a window in WinForms. When you position a window in WinForms, you have to provide an integer x and an integer y value. So if you got that data that you wanted to set the window to from a math library that only worked with floats, you would have to explicitly convert the result of that mathematical operation into an integer so that you can store it in the data format that WinForms expects from you. So there's an example.
Okay, so let's go ahead and move forward. I mean, they're going to be seeing a lot of this.
Alrighty.
Explicit, implicit, and then we can start talking about parse and TryParse if we want to get things a little more interesting.
Yeah. So parse and TryParse. Actually, try and TryParse fall under the same category as something called toString. I mean, is that something that might be good?
Yes, toString's on the list.
Is it?
Yeah.
Oh, okay. Sorry, I'm blind. Okay, so let's say we have a string, and we try to store an integer into it. We will get an error. There's no implicit conversion between an integer and a string in .NET, period. So how do we get from this literal string value into a actual string, or this literal integer value into a string that we can store into the myString variable? Well, every object in .NET, everything that has a type, is going to always have a toString method on it. And so I know this might blow your guys' mind to see this, even if you have seen this syntax before. But what's actually going on, remember, this has a type. This value has a type. It is a proper value in the C# language, and that is as valid as an integer variable, meaning we can treat the literal integer, or the integer literals, just the same way we can treat integer variables, which means we can invoke code on them. They actually have code attached to them that we can perform actions on. And one of those actions we can perform on every single type in the .NET language is going to be toString. Everything has a toString. It doesn't matter. It doesn't matter what object you have, or if it even makes sense to turn it into a string. You will always have a toString. For example, in C++, this would be completely invalid because C++'s integer types aren't actual objects. They're just hints to the compiler about how to act. However, with C#, this is a fully functional object that we can perform any action that we want on. We can do the same with floats. We can do the same with expressions. Actually, that's going to be a good question. What do you guys think? What do you guys think the output of this program is going to be? Remember that I'm only printing out my EXP string. All right. Actually, that's good that I asked that question, because what happens here is this expression wrapped in parentheses is going to be computed prior to having toString invoked on it. So I know this is getting a little bit more advanced, but I thought of this example real fast, and I realized that I really want to drive home the point here that this code right here is executed because this is, the addition operator and the subtraction operator. It is then turned into a value that is just as much of a value as these literals, a value that has a type, just like these literals. In this case, this value has the type of integer. Because it has the type of integer, we can invoke toString on it. Or we can use the toString concept, or I guess I could say method.
Yes,
but,
start saying method.
Okay, I didn't know if you wanted me to start saying that or not.
We've said it with main, and we said it with read line and write line and read key, so yeah, let's start saying it all the time.
Okay, so because this expression has a value and a type, we can call the toString method on it. So I didn't mean to blow up anybody's head, but hopefully that this kind of syntax, you don't necessarily have to understand it right now, but I just want to point it out that this has a predictable format of execution that will eventually make sense. But I just kind of wanted to drive home the whole toString thing, because I was doing toStrings on literals, and I was thinking, wait a sec, there's not many languages where you can actually do that. You can do that in like what, Ruby and Java and C#, to my knowledge, and then the other .NET languages. But C and C++, this would be a compiler error. Okay, so if I run this, we'll see the value of 12 printed out. And the reason we do, I'm going to go ahead and actually write all of these strings out, just to drive home the point that we can do. This is not a true conversion. This is not a what you would call a conversion in the sense of the language itself. These are not implicit or explicit conversions. Instead, what we're doing is we're using some feature of the base class library in order to do a conversion between one type to another type manually. And that's what the toString method lets you do. So if we run this, we'll get 10, false, and 12. So is everybody good with the toString method?
And JT's asked a question over in the questions panel.
All types derived from object? Yes, all types.
Which is where our toString comes from.
Yep. So if nobody, I see some hands are still up, but I don't know.
No, let's go ahead and move forward. So they've seen parse. You want to have a little fun with TryParse?
Oh, yes. Well,
just a little fun.
Alrighty. So we saw earlier how, I'm actually going to keep all this code up. I'm just going to jump down here. We saw back a while ago how we can do something like this.
We do have a question that just came in on the questions panel before you move forward.
Yeah. So 10 false. Yes. They are objects. Literals are objects. Now, before as somebody who's more, performance or kind of understands the performance implications of instantiating objects, and if that was completely, unintelligible, then completely ignore my next few sentences. But there is a mechanism that C# uses to make the fact that these are objects performant also. These aren't treated as fully fledged instantiated objects until they need to be. So there's no significant negative performance hit when using syntax such as this. Okay, so now let's talk about.
So you know what?
TryParse.
You know what? I just looked down at the time before we get into TryParse, since this will get into another 10-15 minute discussion. It's a perfect time to go ahead and take a break. We're at an hour and 3 recorded, plus a little bit of time before class as well. So if anyone has any questions, it's a good time during the break to throw it into the questions pane. But let's go ahead and take about a 10-minute break, and then we will resume and get going once again. So it's a good time if you got to go to the restroom or grab yourself some tea or coffee to go ahead and do that. So Nelson, throw up some comments somewhere in there that says we're on break, and we'll be back in a few minutes. There you go. Dang it, I was trying to get you to do comments. So close.
Alrighty.
All right. So let's go ahead and take a break. We'll see you guys in a few minutes. And I'm going to pause the video here. Continue. All right.
So, okay. Well, I did want to back up just 1 second.
Okay.
As I was outside, I was thinking about the question, homework assignment earlier, and how I had coded up the homework assignment here. And I just want to stress that when you learn a tool in a programming language, and remember, a programming language is just a collection of tools that you can use to express what you want to express, but you're always going to start off writing very straightforward code in a way that could always be made cleaner or whatever as you learn how to use those tools. So I just want to point out to that those homework submissions that did work were fine, and that as the entire point of this class is to get everybody to the point where they can use the tools as effectively as possible to express their logic. So cool. In case anybody was still kind of worried about that.
All right, so finally, going to get into some parse and TryParse to make things a little more fun.
Yep, and I guarantee you that the majority of people are going to look at the TryParse syntax and be confused, but hopefully I can explain that as best I can. I do want to. Yeah, did you start the recording?
Yeah, we're going.
Okay, so I do want to point out this. Okay, so int.parse is great. There's also actually going to be a float.parse. There's going to be a double.parse. There's going to be a decimal.parse. There's going to be a bool.parse. So there's a parse method for all of the base types that you might want to use when converting a string into a value. However, there's a problem with this method. And here is the problem. If I were to hit enter right now, what's going to happen?
Well, don't let all the answers hit us at once. There we go.
So, yep, pretty much everybody got that right. If I hit Y2K.
Kaboom.
Input string was not in a correct format. Now there is a way that we can actually write code that will make this make this error, which errors, runtime errors in C#, errors that occur as your program is running, are called exceptions, and that's a shared concept between quite a few different languages, and .NET has standardized how exceptions should be handled between languages. It's in the specification. So these are called exceptions, and we get an exception right here because we don't actually tell the C# compiler we want to perform an action. If an exception happens, our program just crashes. If I wasn't running this inside of Visual Studio, we would actually get an error that looks something like this. We would get the exception printed out to the console window, and we would get a console application to has stopped working. So if you've ever had a program where this happened, that was most likely caused by an exception. Obviously, that's not good. So what they did, what the C# people did, or the .NET people did, is they created this little thing, this little method and every time you see a parse method on a particular class, such as int, float, bool, and stuff, they'll have a corresponding TryParse method. TryParse method is a little bit more complex than parse. However, if I go ahead and show you the signature of this method, I know we've kind of started talking about signatures. If this doesn't make sense, we'll definitely be going over signatures when we talk about methods. But I do want to point out that int.parse, in a very simple way, takes in a string and returns an integer. So we can stuff the result of int.parse into any integer variable. Int.TryParse, however, takes in two things. It takes in a string, but it also takes in this, an outint result. And hey, wait a sec, it doesn't return an integer anymore. It returns a Boolean. It returns either true or false. The thing that it's going to return is a Boolean that indicates whether or not the parsing was successful. So that should be straightforward enough. You can say something like, if not int.tryparse console.writeline invalid input. That's not the scary part at all. Int.TryParse will return a Boolean that we can then use the not operator on and then put in an if statement so that we can write code that actually executes when an invalid input is
for the
encountered.
complete beginners, you could spell that out a little more longhand.
Yes,
I
I can go ahead and say.
think you might be forgetting about some of our beginners.
Was that kind of what you meant?
Take the not out and say equal equals false, just to make it even more clear. There you go.
Alrighty, so in this case, hopefully very straightforward. It returns a Boolean indicating success, and we can detect if that success wasn't there. Wow, that was an awkward way to say that. We can detect if the method was not successful, and we can write something out.
Yeah, he's not quite done with the TryParse line yet.
Yep.
Which is why right now it's got a red squiggly up underneath it.
Yep, it's going to say that we're only passing in one argument, but it requires two. Now this is where things get funky.
Whoa, it's like space age coding.
Yeah. So I'm actually going to reverse this and then add an else.
And go ahead and remove out your console write lines from above, the original examples, yeah, all of that, just so the program is just really simple. And then everybody that's following along, put your hands up over in the webinar. And I want to make sure everybody has typed this out. Do it. Do it now. So that's right. Get your hands all dirty. Code this baby out.
Yeah. This is one of the most awkward syntax of the C# language for beginners, because you kind of need to understand, or not, you kind of need to use this in order to, well, perform conditional parsing. But it's always one of the things that I think confuses a lot of people.
Now remember, just to keep this nice and clear for you guys, I'll repeat it again. Once you are done typing this out, put your hand down. That way we know that hands that are still up are people that are still typing this out. So once you're done, put your hand down. Down, 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 down. Do not put the coffee down. Put the coffee up to your mouth and drink like this. There is an example for you. Aw, JT, bedtime. It's so early. And if your coffee happens to be administered through an IV drip, I understand. Okay, so we still have a few hands up. Remember, once you have this coded out, go ahead and put your hand down in the webinar. So just think, Nelson, while we have a handful of people that are still wrapping up, after we talk about this, I am going to want us to skip over value types and reference types for now. We're not going to do that today. It won't have near as much meaning for them until we've introduced.
We start writing our methods.
Exactly, until we introduce a few other things. But that'll allow us to get into arrays. And arrays and looping, and that's where things are going to get lots of fun. And Mike, no, we're not using the BuzzNet ready checks today. There are still some issues that remain that need to be worked out, and this way everyone that is in the system both with and without BuzzNet running, we can follow how they're doing over in the webinar.
NATO, are you sure you have a Boolean? Are you sure you're defining this as or declaring this as a variable in addition to assigning it to a value? Is there a way to change the color of a comment away from green? Yes. That's going to be under your tools options. It's going to be buried there under your fonts and colors. Okay. So, and then also while we're waiting, someone asked about block comments. If you go ahead and hit Control-K, Control-C, that's going to go ahead and comment out every selected line. Control-K, Control-U is going to uncomment out every selected line.
Or you could, of course, wrap them in the multi-line comments.
Yeah, or you could do that.
All right, so we've just about got everyone there. If anyone's having any trouble, please don't be shy. Let us know. And remember, once you've completed this, to put your hand down over in the webinar area. And also, you can, segfault, you can put in there Control-K and Control-U. Okay, so start walking them through this now, Nelson. Exactly what's going on here.
Okay. The first thing we're going to do is we are going to declare an integer variable. And this variable is going to ultimately contain the result of parsing a string into an integer. The next thing we do, we declare a variable right here, Boolean parse success, but then we assign it to this expression. And this expression is where things start to get a little funky. Maybe even, I mean, do you think I should break this out into its own variable? Maybe even
I would.
To get it even, yeah. So just to make this expression as simple as possible, I broke that out even further. You don't have to do it if you've already written this out. So in this case, we have string input equals console.readline. Hopefully everybody's familiar with this syntax right now. But what happens here is we're saying bool parse success equals int.tryparse. The first argument we are specifying is the input. It's going to be the string that we want to try to turn into a number. The next argument looks a little funky. This is an output parameter. The reason it's output parameter, the reason I have to put this out symbol here, is because the signature tells me that that's necessary. So it's not something, this out modifier is not something you can apply to any argument that you wish. It is only something you must apply to a method that expects this modifier. And what it's going to do is, this output modifier is going to pass in a number into TryParse, but not the value of a number. See, here we're passing in the value of input. Just to put it really simply so we don't have to talk about the difference between values types and reference types, think about this as we're passing in whatever input contains into int.tryparse. In this case, we're not actually passing in the value of a number. We are passing in the a number variable itself. We are telling int.tryparse, okay, do your thing with input, and then this is the variable I want you to put the result into. So we're sending in the variable a number. We are not sending in the value of a number. If I specified that a number were to equal 10, this would be meaningless because we are not passing in the value. We are only passing in the variable itself. We are saying this is the variable I want you to use to set the result of your parsing. Why do we need this instead of using a return parameter or a return instead of a return? Well, in this case, we are using the return value. Console.readline returns a string. int.TryParse, however, needs to return two pieces of information. It needs to return whether or not the parsing was successful. It also needs to return the actual value that was the result of the parsing. So that's why one of these arguments must be an output. We must specify that to TryParse that we want this variable to be filled with whatever TryParse wants to fill it with. And then we want to assign the result of int.TryParse, the normal return value, to this Boolean, specifying whether or not the parsing was successful. If we were to run this program, and if I were to enter a valid integer, I would get you entered a valid integer. If I were to enter an invalid integer, I would get invalid input. So are there any questions about what's happening here? The mechanism in which C# uses to actually provide the syntax for us is a little bit more complex than what we're going to be getting into in this video. But the goal here is just to express to everyone that what's happening here is we're not passing in a traditional value. We are passing in a variable. We are telling int.TryParse that we want it's the result of int.TryParse to be set to a variable that we control, in this case a number, so that when it's finished, and if it was successful, a number is set to whatever it was successfully parsed as. What is the difference between ref and out?
Nah, that goes beyond the scope, big time. Sorry, we'll get to that a little bit later.
What does a number get set to when parse success equals false? It's going to be the default of the type that was passed in this case 0. What makes the TryParse successful? If the input passed into TryParse was a valid integer that can be assigned to an integer, then that's going to be successful parse. If the input that was passed in was not a valid integer, such as just a bunch of words, then the parse is going to be unsuccessful, and it'll notify us that the parse was unsuccessful by assigning the return value to true or false. Can you run through it condensed down? You mean how I had it earlier where it was more or less one line? What is an A number going to be? It depends. If the parse is successful, if input can be parsed into an integer, a number will be whatever the result of that parsing was. So if I passed in, for example, 543, I will get back 543, but as an integer instead of a string. If input was not successful in being parsed, a number will be set to 0. What is the difference in using TryParse instead of TryCatch? TryParse seems more complex to do the same thing. I mean, I guess I will answer that question. We haven't gone through TryCatch yet, but for people who are familiar with what TryCatch is, the answer to that question is, I mean, there's a lot of different reasons. First of all, performance. Exceptions are going to incur a small performance hit during runtime. If there's no need to write code that causes an exception, you shouldn't. Second of all, exceptions should be used for errors that result in the program not able to continue to work. You should never allow user input to in any way impede your program from working. Therefore, you should not use exceptions for this case. At the top level of a program, exceptions should be caught and turned into user-friendly error messages. And just the principle behind an exception is you don't never want your program to stop or halt executing unless there is a condition that exists in which your program cannot continue to process information. Why do we have int a number equals 10? That was just an example to show that the value of a number is never used. This could be anything, or it could be nothing. It doesn't matter. The value of a number is going to be overwritten by TryParse when that code executes. So a number set to 0 will be false, but it's something like number 12, it'll be true. By it, I mean parse success, generally speaking. Well, but that behavior shouldn't be relied on, simply because what if I had typed in 0? At that point, I get success. But if I determine success whether or not a number was set to 0, I'll be preventing people from legitimately typing in 0 into my program. But yes, if it was not successful, a number will be set to 0 because that is the default value for integers. But then again, that knowledge is kind of worthless, and you might as well throw it out simply because philosophically, a number is undefined by nature of the fact that the parsing was unsuccessful. A number no longer contains a valid number, and whatever value a number is should be discarded simply because TryParse said that it was unsuccessful in doing anything with the input string. What's the difference between convert, toInt, and parse? Well, we can actually get into that pretty soon here. There is a slight difference. So is a number null then? No. A number is 0. A number cannot be null. The reason it can't be null has to do with the difference between value types and reference types, which we're not getting into yet. But just remember, the value of a number in the case that parse success is false is considered to be undefined in your mind. Considered to be garbage, because it's, like I said, if TryParse did not succeed, the result of a number should not be used in any way. So is everybody good? There's a few people with their hands up. I'm wondering if those are people that are AFK or actually have questions.
Actually, I think I think it's AFK because those hands have been up now for a long time. And if you have questions,
actually,
don't
there we go.
Toss them over there.
I just reset everybody's hand. Raise your hand if you do have questions.
Hey, Carl. Carl. Say hi, Carl. You're real low. What's your question? Oh, no. Okay, we tried. Unfortunately, that's breaking up way too bad. But if you want to throw your question over in the question panel, that would be fantastic.
We did have another question come in. But how does TryParse know if a number is 0 as a not a number or the number is 0? I think what you're asking is, how does TryParse let us know if the parsing was unsuccessful? and the answer to that question is the return value. TryParse lets us know that parse success was, or that the parsing was successful or unsuccessful, with the return value being either true or false. That's how we get that information out of it.
If you are going to explain try and catch, you could maybe write the.
I don't want to get that far off on.
Oh, okay.
Tangent, please. Okay, so Wolf Knightley. Hey, Wolf. Are you there? Oh, quick, stumble for the mic.
Yeah. All right. Got it on.
All right. What's the question?
So, well, I think so. A number has nothing to do. I mean, its success has nothing to do with a number being 0. That's where I was getting confused.
Yes, well, we know if the parsing was successful because of the return value. If you look at the code, we have, okay, if the parsing was successful, then now we can use a number because we know it has a valid number in it. If it was unsuccessful, then we don't use it because, like I said, there's no reason to. It doesn't contain anything that we care about because TryParse was unsuccessful in parsing the string.
Okay, I guess that's what I was getting confused. I thought you were saying that it was if a number was 0, then it would not be successful. So I was thinking it would be false or something, and that's why I was getting confused between. Well, what if you entered in 0? Then it wasn't making sense.
But yeah. Maybe I said what I said backwards. But if it's unsuccessful, a number will be 0. And it'll return false if it's unsuccessful.
But we don't really need to care that it's 0 because you won't be doing anything with it anyway.
Right, because it's not. We don't care about it. We shouldn't rely on that value at all.
All right, that makes sense now.
Okay, fantastic. Thanks, Wolf. All right, we've got another question. Florin, are you there?
Yes. Does it hear?
Hello.
Does it work?
Yes, it's working great.
Oh, hi there.
Hello.
Sorry. Now, if you have TryParse, do you also do parse?
Now, if you understand how TryParse works, feel free to start using it because now you can trap for somebody that's not entering a proper number.
I was asking if we are to do if parentheses in TryParse, then enter the code.
Oh, I see what you're saying.
And do we do in the brackets into parse and get the number, or hope you understand better?
Let me make sure I understand. I think you were asking, were you asking about having the int TryParse inside the parentheses with the if statement?
As a condition for the if statement.
Oh, were you asking if this is valid code?
Yes, I know that's a valid code. I want to know if you inside the blocks you also put the int .parse to get the number.
Oh, okay. Yeah, now I see what you're saying. You already have the number if it was a successful parse.
Yes.
So there's no need to do an int.parse inside of the block because we have the number. If I were to do another int.parse right here, this another number will be the exact same value as this a number. So there's no need to do it again.
Thank you. That's it.
Okay.
I understand.
Perfect. All right. Thank you. Okay. So hopefully that will help things make a little bit more sense for you guys. Over in the questions panel, do you want to take a quick look over there, Nelson?
Yeah. So a number has to be real number within the value of int. Otherwise, it fails.
Remember, guys, it's really about the input, the variable that right there, input, what has come in from the read line on line 8.
Yeah. Int.TryParse does not care in any way what a number contains before you invoke it. It's going to overwrite the value of a number, whether or not it's successful. The only thing it cares about really is the input. That's what determines if the parsing was successful or not. Hopefully that. Cleared that up.
Okay, so let's see. Okay, yeah, and go ahead, Nelson. Were you about to say something?
Well, I mean, somebody said that they thought that this code was a little bit more straightforward. I would agree with that. I was just trying to get everything kind of in a very imperative language, so that people can follow along by just reading line by line,
Right.
without having to go inside of the individual arguments and figure out the result of the expression.
Exactly. Just trying to keep it as easy as possible for. I mean, some complete beginners actually have a hard time once you start nesting and making complex method calls within calls.
And it also cares about the data type you declare prior to TryParse, right? Yes. If you look at the signature, this requires an int. If a number were to be a float, we would get a nice little compiler error.
Okay, so let's go ahead and move on from here. So the next thing that we're going to be moving over into is going to be a discussion about arrays. Boy, this is where things are going to get fun. For those of you that look at the Streeter, that was, oh Jesus, that's great. For those of you that are looking at the syllabus, don't worry, I'm making notes on this myself. I know we're skipping over value types and reference types, stack and the heap right now, but now that we're into the thick of things, I don't think that's very relevant at the moment. So it will be something that is going to be covered. There's just a little bit more that I think if you're introduced to first, it'll make more sense to you. It'll have much more value. Also, the concept on null and void, again, we really need to get into methods. And once you understand how to define methods, that'll make a lot more sense as well. So these are things that are going to be covered in the 101 class. I just think it'll be much more valuable to you once we've covered a little bit more first. But at this point, it's time to blow your mind, for those of you that are true complete beginners, with arrays. Oh boy.
Alrighty.
So go ahead and kill out all of your code like Nelson has done here.
Okay, I'm going to go ahead and write a very simple program, and it's going to be very long-winded and very ugly and not very robust. And then I'm going to show how to, I just want to bring prior to really going over arrays, kind of show you the situations in which, if you do not know arrays, these situations are impossible to figure out. Let's say we wanted a program that asked you to type in 5 names and then printed out those 5 names at the end.
Go ahead and put some comments in, just for people that might be saying, well, what'd you just say? Now, at this point, what Nelson is asking for is very easy with what you've already learned.
Yep, it just will be very long-winded.
Exactly. But what if that 5 was a dynamic number? What if we didn't know before the program ran? Oh, wait, what was that, Nelson?
Well, yeah, that's definitely going to be an issue.
I didn't know if that's where you were going with this.
Yeah, I was going to write out the example first,
Yep,
and then
okay, perfect.
ask.
Nope, perfect. Perfect.
All right. First thing we're going to do okay, so now we have some strings. I'm going to go ahead and say console.writeLine, please enter 5 names. And then just to make things a little bit shorter, I'll do this. So if I run this program, please enter 5 names, name 1, name 2, name 3, name 4, name 5, and then I get the result back.
All right, run it again and do something other than name 1, name 2, name 3, because that could be like name AA, BB, CC, DD, or that. Very nice.
Okay.
Of course.
So now we. Okay, so now we have our 5 names stored in variables that we can use in any way we wish. But there's some problems. The first problem is repetition. And the tools, as I said earlier, I still really like defining a programming language as a collection of tools that we can use to express logic. And there are tools that exist, and one of the things that we like to do in programming is reduce repetition as much as possible. Repetition is bad. And repetition means that if I were to change the logic of how my program interacted with names, for example, I would have to change it 5 times. But it's not only that. Like Jason pointed out earlier, what if I wanted this program to be 6 names? I left out Fluttershy, for example, so I actually need to have another name variable and another console.writeLine at the end.
Shame
but you'll see
Nelson,
that
for leaving out the best pony.
I'm sorry. That wasn't intentional at all, but I'm sorry, Fluttershy. So in order to actually provide this logic, we would have to copy and paste 2 lines, change the things inside of it. It would just be very brittle. But then it would only support 6 names. What if we wanted 7? Then we would have to do it more. We would have to copy and paste code some more times. What if we only wanted 3 names? Well, we would have to delete a bunch of code. So here's an example of a common pattern that if you find yourself doing, this is a common pattern that arrays can help you with. And the pattern that we see here is that we are storing data that is very similar, not only in the type is the same, but it's also similar data in that they're all names. So semantically and syntactically, these variables are associated in a way that makes them a candidate for using an array. So what is an array? Well, imagine all 5 of these values being stored in a single variable. I'll show the syntax really quick here. So make sure that you should probably type this out, because the bracket syntax is something that you just have to get used to if you've never worked with arrays. So I'm going to go ahead and ask that people type this out. I'm going to delete the comments so we can fit all the code in a single screen. Because what I'm going to do next is I'm going to explain what this does. And then I'm going to show how to refactor or how to modify this code to use an array instead of what we have here. Now, it still won't be perfect, but that'll bring us nicely into the next subject that we want to cover. And actually, no, hold off the questions until I do a quick overview of what an array is, then ask for questions. Okay, we still have a few hands up.
the hand count is growing. It's awesome.
Well, that was contradictory to what I expected to happen.
Yeah, hands go down once you're caught up.
A couple of people I was pleased to see have had the same problem that I have. I've got confused as to which way the toggle is with the image, the green and the red of the hands.
Oh, they're red and green on your side?
When you're not an operator, they kind of look. The icons are kind of contradictory to what they do. It kind of seems at first glance as though down is up and up is down.
Gotcha. See, I didn't know that because I'm on the other end.
Yeah, it's not visible on this. Now.
Everybody figured it out though. Awesome. Okay, Nelson, you can continue.
Alrighty. So, line 9 might look terrifying to you. But what's happening here is pretty cool. What we're telling C# to do is we're saying, okay, we want to store a collection. We want to store a bag. We want to store a list. We want to store a lot of things that are not only the same type, but also have the same sort of definition. They have the same sort of semantics to them, in this case, names. And so what we do is we first specify the type of this variable. The type of this variable is going to be an array of strings. This syntax means array. Whenever you see the syntax on a that is directly following a type, think array. And then we have names. The next thing we do here, and to actually explain why this syntax is necessary in this case would kind of require us to sort of talk about value and reference types, and we kind of want to avoid that. But in this case, just take this syntax as what you do in order to what you have to do in order to receive the amount of data that you need to store all of the objects you want to store in this array. And so remember, an array is a bag of things. If I had a list, if I had 1, 2, 3, 4, 5, so this is a list of strings separated by commas. If I wanted to represent this programmatically, I would use an array, because an array allows me to store as many values as I need to. Of course, we have to predefine how many values we want, but this number can be anything we want at runtime or compile time. I want to point out, though, really quickly that the reason just in general, the reason the syntax is required is because the C# compiler does not know ahead of time how much memory to set aside. It doesn't know what this number is going to be, because this number could be a variable, which we'll be seeing very shortly. So what we have here is we have a collection of string objects that we can access. And we access them with the brackets.
I do have a question, actually.
Yes.
Because this is an area that I've always kind of lent on intelligence for. But so you're saying that when you, at the point at which you first assign names, that when you use the new, that is the point. At that point, you have to specify the size of an array.
Yep.
Cool. Okay.
Arrays will never change in their size. Arrays are a fixed size, but that size can be computed at runtime, which is what makes them awesome. So now you'll see something weird. I mean, what's the difference between this code and this code? There's a lot of different things we can do with this code that we can't with this code, but I first want to explain sort of the syntactic differences. What we have here is we are actually using a single variable to store 5 other variables. And we access them with the brackets, the square brackets. And you'll notice here that we start off at 0. And we go to 1, 2, 3, 4. So the 4th element is actually the 5th item. The 0th element is the 1st item. If that's confusing, think about it this way. The number that, think about names as being a, I'm going to use a word and Jason's going to hate me for it, but I'm using it in the English definition, not the programming definition, so forgive me. Names is going to be a pointer into this list, or this array of items, this collection of items. So by default, so think about the number you place in here, the amount of items you want to go in the future, or go past the original names. If you think about it that way, the 0 indexing makes sense. If that was confusing, don't worry about it. Just take the fact that it's 0 index. Just try to ingrain that into your.
Think about it. A lot of you out there are familiar with what a post office is. If you go to the post office and you have all of these different post office boxes that people can get mail in, so you could say mail is the common data type here, and so you could just simply say that, you know, post office, and if you were to take that post office, rip it up from the ground and move it from location to location, you're taking all of those mailboxes with you. Everything goes along for the ride. So we can just refer to the whole thing by simply saying the post office. I'm going to the post office. But when we get to the post office is actually divided into a bunch of different boxes where people's mail goes. And everybody has a very specific number. And let's just simply say that the number starts at 0 and it incrementally grows. So if my post office locally here in Dixon has a total of 20 different P.O. boxes, we could say that the addresses for those would range from 0 to 19. Because that is a total of 20 different individual boxes that fall all up underneath post office. So obviously if we went to 20, seeing how we started at 0, that would actually give us 21 boxes. That's one too many. That's outside of the range of the number of boxes that we have. So we couldn't tell somebody to go up to the post office and access box 20 because they'd start looking for 20 and they'd see a little number on each one. But lo and behold, there is no 20. The highest number they could find is 19. And then they're all confused, exactly how your computer program would be confused if you tried to, like in this case, if Nelson tried to access names in number 5 outside of our range. So as he's entering, and boom, index out of range exception. So that's just a very easy way to think about it. It's kind of like a post office and how the post office has all of the post office boxes inside.
Yep. And the two properties that make arrays useful, in this case, over using static variables, is that there's two parts of arrays that are runtime components rather than static components like this. This is all static code. This isn't never going to change during runtime. But here's the cool thing about arrays. This number can be determined at runtime, and so can these numbers. So we'll see how that actually provides a significant advantage over static variables in a moment here. So if I were to want to access these items, instead of just assigning them, I could do this. Oops. So now our code looks very similar, and it does the exact same thing. But if you guys want to go ahead and nuke out this code, you can keep it if you want it, but make sure that you type out this code right here. And then after that, we can ask or see if anybody has any questions about arrays. And then after that, we can get into actually how to use arrays for great good. Yes, the number inside of the brackets is called the index. The act of indexing an array is by providing this bracket syntax. Is it too early to talk about array class that is part of system collections namespace? Well, actually, the array class that we're using right here is part of the system namespace. And the system.collections namespace is something that we're going to get to later, simply because it's a little bit more complex than arrays.
And looking at the clock right now, right before you dive into this next part, I think this is a really good time for us all to take a quick break. So there's still a couple of people that are typing this out right now. So let's go ahead and use this break as an opportunity to do it. And remember, once you have everything typed out, go ahead and put your hand down over in the attendee list, and we'll just all meet back here in, say, 10 minutes. So we're on break, and I'm pausing. All right, and we are back from the break, so let's continue.
Yep. Okay, so does anybody have any questions about arrays? What we have here is what we have here is a phone call with the phone that wasn't muted. What we have here is the most basic example of what we can do with arrays. It doesn't yet provide us any additional benefits over using multiple variables until we introduce the concept of looping. But before we go on to looping, I want to make sure that everybody is comfortable with the concept of an array containing multiple ordered values that we can access through the bracket operator. Can you have any type of array? Yes. You can have an int array, a float array, and an anything array. However, every single item within that array must be of the same type. Can I have an array of arrays? Yeah, you could. I don't know if we're going to be talking about multi-dimensional arrays.
No, not. Come on, Nelson. There's already, I did talk with Meta at break to see how she was doing, because again, it's excellent being able to gauge, somebody's understanding when they're a complete beginner. And she said so far it's not that bad, which is good. She said it's interesting, but yeah, then you go and throw a multi-dimensional arrays and you're going to just blow her brain. Well, that's just messy. We don't want to do that.
No, yeah.
What was that?
Yeah, well, I can't be held responsible for people's brain matter exploding. Although I'll try not to. In the new string 5, is there always one number? No. If you had a multi-dimensional array, which we're not getting into. You can't have multiple numbers. But for right now, it's a number. And remember, this is an expression. We could have just easily done 2 plus 3 if we wanted to. And I'll get into why that's important very shortly here.
So do you want to throw a quick integer array example up?
Yeah. If I were to have an int array, it'd look like this.
Quick, give him a floats array. Hurry, with only 3 elements. Go, go, go. 3 elements. Go, go. Oh, you're so slow. Come on, I thought you were faster than this, Nelson. Come on. You can do it. Come on.
I'm working. Come on, hey.
There you go. Sweet.
I don't have Resharper installed, so you got to cut me some slack here.
Excellent. All right, good job. Let's all give it up for Nelson. All right, nice.
Yep, so we can have arrays of any types. I would have totally survived swordfish.
There's an image I didn't want.
Yep, and that is my age at index 4. Man, talk about being old. Okay, so what were you going to do next, Nelson?
NATO just brought a question in. What's the meaning of ages? In the English sense or the programming sense? Okay, I'll ignore you. Okay, so yeah, I'm going to go ahead and nuke these. These were just to demonstrate that we can have arrays of any types of values. Furthermore, we can specify, we can actually, oh, great, I don't have Resharper installed. We can actually assign these values in any order that we want.
Very good.
So if anybody thought that just because I was initializing everything starting from 0 to the latest index, that's not a requirement.
Okay,
whatsoever.
hang on. We have a couple of questions.
Can you leave any uninitialized?
You what?
Can you leave any uninitialized?
Yes. The value will be their default value, and the default value depends on the type.
All right, let's have a little fun real quick. I'm putting all hands down, and if you have a mic and you had an actual question, raise your hand real quick. Wolf, I think you were in there. Ian's in there. Ian. Hello. All right, you had a question?
Yes, so when you got the 2 plus 3 there, that's actually going to evaluate when the program's runs, and therefore it's going to be 5. On line 21.
Okay. You mean this?
Yes, because what I'm thinking is, can you, for example, add more to the array later if the program's already running through code? For example, let's say, look at the top one, but on line 9, where it says the array is going to be 5. So later on, if I think in the code that I need to add more to that, can I do it, or is that restricted to 5 because it's been set?
Good. Yeah, good question. When you instantiate an array, and that's a word that people here might not understand yet, but I just wanted to throw that terminology out there. When you instantiate the array, you must provide the length of the array, and that length will never change.
Okay.
However, we could do.
Oh boy, is that again?
But this would erase all of the data that was previously in ages.
I get that because they both got the same name.
Yep.
Yeah, same as a standard int variable where you would assign a value more than once would erase the first value. Got it.
Exactly. Cool.
I got it.
Okay.
Okay, thanks very much for that. Yeah, thank you.
Yes, sir. All right, we have one more. Let's see. Vern.
Okay, so my question is, if you only put a value in for one array, and you had 5, if you put something outside of 0 to 4, you would get an error, correct?
Yep, you would get a runtime exception. It would not happen at compiler.
So those values have to be 0 through 5. I mean 0 through 4 if you have 5 in your
That's
array.
right.
Yep.
Okay.
Okay, cool.
Can you place an integer as the value for an array? I'm not exactly sure what you mean by that. All arrays are 0-based, yes.
Oh, and to answer the question, this is not a question about arrays, but for Jason, if we don't stay until the end of the session, do we still get the 10 point? Yes, if as long as you've made it through a good portion of the class, absolutely. Or even at least a quarter of the class. So yes, I understand that for some of you guys it's now getting late in the evening, and that you have to go to bed or whatever. It's totally understandable. I'll have this video encoded and put up for you guys to view later on this evening. Come on, we work with you every way we can. All right, so any more questions coming in? And then there's one, Nelson, that you will definitely find a good question over in the question panel.
Can you have an arrays of a dynamic size without losing the previous data? Arrays? No. You would have to create a temporary array and copy the values of the old array into the new array if you were to resize that array by instantiating a new one of a larger size. However, arrays are not the only way in C# to contain a list of elements. In the next video, we're going to be going over what are called collections. Collections are special classes that are provided for us inside of the BCL, and they provide us functionality for dynamically, a very easy way to dynamically resize not an array per se, or not necessarily an array per se, but they allow us to work with a value that acts like an array, but of an undetermined size.
Okay, Nelson, so where were you wanting to take it from here?
Well, I wanted to show basic looping.
Well, before we get into basic looping, before we leave out of arrays, how about, length?
Yes, length is good.
Yes, it is.
Now, arrays in C# are objects, because everything in C# is an object, with the exception of almost everything in C# is an object. Which means we can do the dot operator on any array. And what we'll get is a nice list of all of these methods and other things that we can operate on this array with. And some of these are going to be things that you will not ever really care about that much. But one of them in particular is very, very useful, and that's length. The length of an array is going to be how many items that array can contain. If I were to do console.writeLine ages.length and run this, we'll get 5 right there. I know the input's kind of all messed up, but you see the 5 right there is the result of us printing out the length of this array. You'll notice, I do want to point out that up until now, the only method that we've invoked on other objects is, or the only things that we've done to other objects is invoke methods with the toString. This is not a method. That is invalid. So length is an example of what's called a property, and it's something that we can access as if it were a variable that is attached in some sort of way to the object we're working with. You'll also remember there is a toString method on here as well, because it is an object. But what we're mainly going to be worried about is length. And length is the most important property or member of any kind that you will be accessing consistently when working with arrays. Is everybody good with length? It is an integer, meaning we can assign this to an integer value if we wanted to alias it out into a variable, such as ages length equals ages.length. And that'll just, again, the ages.length will give us however many items, the maximum amount of items that we can stuff into an array. A very common operation that we might want to do with length is finding the value of the last item in the array, which we can do like this. So here's an example of us actually indexing on a value that isn't known at compile time. The C# compiler has no way to determine what the results of this operation is going to be until it actually runs the program. And this just drives home the point that we can provide any sort of combination of variables and expressions into this indexer. In this case, the expression is args.length minus 1. And if you remember, because arrays are 0 index based, the last item is always going to be the length of the array minus 1. So is everybody good with arrays, or lengths in particular?
All right, let's go ahead and move from here over to looping.
Alrighty.
And no, you didn't have to type this out with Nelson, but this next section, yeah, I definitely want you guys to type out. So let's have some fun. Kill this all out, Nelson.
Alrighty. I will want to point out we will be coming back to this example, but not yet. Because the first thing we need to explain is going to be what a loop is, what the syntax of a loop looks like, and what happens when the program enters a loop. And
all right. Okay, yeah, go ahead. I just checking over there for questions. So first, why looping? What is looping? Just in English.
Well, it's a very aptly described term. Looping is a way to provide a loop. It's a way to repeatedly execute code over and over and over again until a particular condition is met. That condition takes the same form as an if statement condition, where it's a Boolean that'll evaluate into true or false. Different loops have different structures. There are a few different types of loops, whiles, do whiles, fors, and for eaches. But we're only going to be worried about whiles for right now. And a while loop will actually allow you to express as much logic as you need to. All the other loops can actually be implemented in terms of a while loop. So a while loop is the most fundamental type of loop that you will encounter in any programming language. Yes, please type this out, or what I'm about to type. So I'm going to go ahead and just throw some code up here. So go ahead and type this out, and I'll explain it line by line once everybody gets that working.
So go ahead and turn your hands on. Very good, very good. Now remember, once you look at you guys are awesome. As the day gets later, you guys just become more and more awake. That's fantastic. Okay, so as you finish typing this out, simply put your hand down. Very good.
So that thunderstorm finally died down, Jason?
Yeah. That was, I actually took a little bit of video I'll have to show you. It was insane how intense it got.
Yeah, after seeing that, what happened to that? What was that, a hotel
Yeah,
or whatever?
the hotel roof that's just like a couple miles down the road. Yeah.
Yeah.
I didn't know it would come that close to you guys.
Yeah, it was.
How long did it take to go past?
I would assume not long. The storm itself only lasted maybe 8 minutes or so. The worst of the worst. But I'll tell you, the hail, it was about 1 inch hail. It was just coming down like crazy. The wind was so strong between that, the rain, and the hail, we couldn't even see the house across the road. All the trees were just leaning over sideways. It was intense.
Big Chuck was asking if he hands in his homework late, will it still be graded, even if he doesn't get a certificate?
Yeah, I think that all homework, even if handed in late, should still be graded just because, it's feedback. Feedback's good.
Oh, okay.
Okay, so we've just about got everyone there. Remember to turn your hand down just as soon as you get your stuff typed out. That's good enough, Nelson. I think we're just about everybody's got it now. So go ahead and walk us through this. What do we have going on here?
Okay, so line 7 should hopefully be familiar to everybody by now. We are initializing a variable called number of type integer, and we're giving it the value of 10. The next thing is we're starting another expression we haven't gone over yet. And this looks very similar to an if statement. However, it behaves slightly differently. This statement will use the condition provided in parentheses immediately following the keyword, and it'll use it to determine whether or not it needs to execute this block of code again. Meaning that while this condition is false, while this condition is true, it's going to go ahead and continue executing this code repeatedly until this condition becomes false. And once this condition becomes false, it'll exit the loop and continue execution at the program later. So if I were to run this, we will see numbers starting off as 10 and repeatedly being decremented until it hits 1. When it hits 1, what's going to happen is console.writeLine number is going to print out number equals 1. Then number is going to be decremented and turned into 0. When number is turned into 0, it'll loop all the way back into this header right here, into this while statement, and it's going to ask the condition if it's true or false. In this case, because number is now 0, 0 is not greater than 0. And because 0 is not greater than 0, the expression is false. Because the expression is false, the while statement no longer will execute this block of code and will allow execution to continue to after the final curly brace of this block.
So if you wanted to, Nelson, you could go ahead and end the program and then put a console write line after the while saying the loop is finished.
So remember, whenever you see while, always remember that if this statement is true, this block will execute until the statement is false, and then it will finish. Of course, we could do this. It's valid code. But obviously the loop is never going to terminate, and we're just going to sit there, well, pretty much forever. So you'll always want to put in an expression into this while loop that is going to change every time that the loop iterates, or at least it's going to eventually change to false so that the execution can continue. So is everybody kind of good with what we have here? I mean, I know I just threw out a new language structure. But like somebody in the IRC said, it is a very sensible piece of code. It reads, as it should.
All right, I'll give you guys a quick little test. If you think you got a good handle on the basics of this, put your hand up over in the yeah, that thing. There we go. Good. Ooh, lots of hands. So you guys are all feeling all warmed up to these loops. All right, so do this then. How would you go about having a scenario that contained one or more loops that printed out the following: 1, and then it printed out 5, 4, or well, no, let's make this simple. Then it printed out 3, 2, 1, 0. No, Nelson. Okay, yeah, you could do it that way if you want. I was just going to do it on new lines, but then it printed out 2, comma 3, 2, 1, 0. Then it printed out 3, comma 3, 2, 1, 0. All right, write that. Very, very simple. Except you might want to put them on new lines, Nelson, just to.
Yeah, you want every number on a new line?
Yeah.
Or just the groups?
Yeah, that's cool. Let's do just the groups. Yeah, I like that. Very, very simple. So let's take a few minutes. As a matter of fact, I'll go ahead and pause the video. Actually, I'll leave it running for just a second in case there are any questions that come in that we can catch. But if we get nice and quiet, then I'll just pause it. So once you've written this out, put your hand down. Very simple loop or loops.
And no, console.writeLine with string literals will not be accepted. I can see somebody doing that.
So I am, just for the sake of keeping the video from being super long, I'm going to pause the video right here. Okay, we are resuming with the recording because here in just a second we're going to be taking a look at how to do something like this. Let's see, who could... Hey, Segfault, did you do yours?
He says yes.
I say that we... why don't you go ahead and flip over to Segfault's screen?
Alrighty. Aw. Nice resolution.
That's okay. Look, he's all over this.
Okay.
Oh, uh-oh, getting a little fancy. Don't worry about that down there, Segfault. Yeah, we can hear you. You can say hi.
Oh,
Hello.
oh. Is everybody going to be able to understand what I'm saying?
I can understand, so they should be okay.
Everyone
okay.
except Nelson.
Yeah, that's true.
Yeah.
Everyone
Yeah.
except Nelson.
Yeah. Gav will help you with the translation.
I've done it every number on its own line, but I suppose I could change that if I really wanted to.
Well, first go ahead and run the program. Let's see what you got.
Oh yeah. There we go.
All right, so 1, 3, 2, 1, 0. 2, 3, 2, 1, 0. 3, 3, 2, 1, 0. Very good. Okay.
Yep.
So walk us through how you went about this.
Well, I figured out I'm going to need an integer to count from 1 to 3. So I thought, well, I'll do a while loop while 1 is less than 4. Well, while number A is less than 4. So it's either 1, 2, or 3.
Okay.
And then so I'll go into the first loop. I'll display the number with the console write line and then increment it. And then I'll initialize another variable to 3 because I want to count down from 3 all the way to 0.
Okay.
And then go into the next loop, say while number B is less than or equal to 0, and then
greater than or equal to 0.
Sorry, yeah. Well, greater than equal. Actually, I think I did that wrong the first time, and it went on forever. But, yeah.
Okay.
And then display that number, and then decrement it.
Which, for those of you that don't know what that means, that's the same thing as saying number B. Yeah, he's typing it out here. Same exact thing. It's just shorthand for doing that.
It'll eventually go down to 0, and then it'll break out, but then it will go back up and check the first condition again.
Okay.
And then eventually it'll break out and just get to this read key here.
All right, so if you wanted it to all be on, if you wanted to look the way that Nelson was doing it, how would you do that?
Probably
do it.
Right. This is not going to work perfectly because we're going to get a comma and a space after the last number. And then I'm going to, after the second loop's run, but before I go back to the top of the first loop, I'm going to put in a read line so I'll get a line break before the next set of numbers. No.
Don't you love being put on the spot? Isn't it fun?
I'll do it right this time. Okay, that's almost correct.
Getting close.
Come on.
Shush, Nelson, I'll make you use confusion. Alright, there we go.
Okay, very good. All right, thank you, Sarah. Oh, you just wanted everybody to see your pretty backdrop. I know how it goes. Very nice.
I didn't know which background it would be on. It changes every 5 minutes.
Oh, lovely. Okay, so Nelson, go ahead and switch back over to your screen, sir. Thank you very much, Andrew. I do appreciate it, sir.
No problem.
Would you like for me to do it for you, Nelson? Hey, all right. Okay, so Nelson, why don't you go ahead and code this out how you would do it? Because there was already a few people that had made the comment of, wow, that was way more complicated than the way I did it. So what would be the most simplistic way that you could think of doing that?
The simplest way,
within reason of people being able to understand.
Link.
Yeah, numerable.range is your friend here. I would start off with a top level. I would probably implement it pretty close to how Segfault did.
Well, keep coding. Keep on coding through. So you can explain now while you're coding it for people that are watching.
Basically, so it goes 1, 2, 3. So we'll start with 1, and while it's smaller than 4, and then we can go ahead and say console.write top level counter plus comma, and then I would say int inner counter equals 3, while inner counter is greater or equal to 0. I'll probably stick this up here just to make it look a little bit nicer. Then I would do something like console.write inner counter, and then I would say if inner counter equals 0, or sorry, does not equal 0, console write comma, and then console.write line.
Ooh.
Failure.
That was absolutely awesome. There you go. Isn't that incredible?
While it's greater or equal to 0.
So you're just going to...
I got the increment and decrement mixed up. There we go.
All right, so you can see that if Nelson scrolls up over in the editor, you can see that the output is exactly the same.
Yeah. And that's just with the tools that we've provided, and maybe I can go ahead and I think this is probably the simplest way, unless somebody has a more creative way to do it. If I were to be writing this code without the constraints of showing, what we've already taught, I would have done it differently. But this is what comes to mind in a very imperative, very straightforward manner in my mind.
Yeah, that's.
Can you let him show just how he would have done it? I'm interested.
Oh, but it runs the risk of.
No, it's just to say if you're.
All right, fine. Go ahead and do it the
You
way.
can tell me later.
Go ahead and do it, Nelson. But for those of you that are complete beginners, just ignore this, please.
No Resharper makes me kind of sad.
Yeah, I can think of that.
Because I don't know how many parentheses I'm missing. Apparently, I need one more. Oh no. 2 more? Really? There we go. Yeah, it's kind of backwards, but you get the idea. If I were to go ahead and say enumerable.range 1 to 4.reverse, or sorry, 0 to 3 reverse. Sorry, 0 to 4. There we go.
Very nice. Now,
then I usually format it something like.
Nice. Thank you.
But yeah, don't be afraid.
this is way outside the scope.
Yeah, that's just because I worked up the little text parser today, and it was so I've been doing a lot of these sort of string things.
QQ gap. Very nice, NATO. Very nice.
Alrighty. So yeah, so is everybody kind of good with what this
yeah,
does,
just make that
least?
visible. And what I'm going to do is put everybody's hand down. And now put your hand up if you're copying out Nelson's code. This code, not the crazy stuff he did above. If you want to copy that out, wait until the video goes up. That is way outside the scope of a 101 class.
it's something to aim for.
Yeah, for sure. And Nelson, if you want to take a look over on the questions panel real quick while everybody is.
All right, yeah, I have my eye on both of them.
Segfault is staff still.
Segfault is what?
I am on staff still. I can't put hand up or down.
Yeah,
says.
let's see. How do we remove again? Give me a second. Let me take a look at that.
Oh, don't kick him, please. I like what you did to Wolf Knightley that one time.
I mean, we don't want to do that. Yeah, I'm just not just not sure and don't really want to risk it at the moment. Okay, so not many hands left. So typey, guys. Lots of good stuff for reviewing, for sure. And again, for those of you that are coming in late, just a reminder, we're going to be doing something special for you guys this coming up Wednesday. So that's the day after tomorrow at the same time that our Monday classes begin at, the 3 p.m. Central Time. We will be holding open office hours where we will be doing a webinar. I'll post the details into the member sponsor lounge for you guys, and you are invited to come in almost as if it was a class, but instead of it being a class, we are here to help you out with any problems that you may have and to answer questions. Of course, all relevant to the content that we are going over. We want to make sure that people don't suddenly start taking advantage of it for an opportunity to try to squeeze in advanced lessons. We've got to make ourselves available to our beginners to help them out. So that will be this coming up Wednesday at 3 p.m. And Musaru, there'll probably be lots of pony talk for the simple fact that Nelson is here.
I'm sorry, Gavin. You just haven't discovered the magic of friendship yet.
Friendship.
Okay, so just one more minute on this, and then anything that you may have missed out on, you'll be able to get from the video when I put it up. And again, if you have got this copy down, please make sure to put your hand down in the webinar system. Thank you very much. So did you enjoy your pony episode Saturday, Nelson?
I actually didn't get to watch it Saturday. I had to wait till Sunday. But I did very much. It was pretty good.
You posted so little on Facebook this weekend that I was actually concerned if you were still alive or not.
Yeah, I really wasn't in a very coherent state for the most part.
But you're still alive, so that's what counts. You know, these students do actually rely on you surviving and hanging out with us longer than just, you know, a couple of days. I'm just saying.
All right, so apparently I just need to survive till mid-April.
No, you've got to finish the C++ class as well.
Okay, so we're pretty much, for the most part, all hands are down. We've got just a couple that are left, and we need to go ahead and move on. So for those of you that need to finish catching this stuff, you can once I get the video put up and live. But we want to prevent today from being a 4-hour day. Nelson, at this point, if you could go ahead and recreate the little name thing that you had at the beginning.
Alrighty.
Streeter says, should we be writing this?
Why make it making them write all that out? That long way.
Well, I thought you wanted me to recreate it and then show how we do it.
No, they did it earlier. I would go ahead and make it with the loops and tell everybody to put their hands up and follow along.
Oh, okay.
So put those hands up if you care to follow along. All right, look at the flood of hands. Awesome. Meta, get that hand up there. All right. Ooh, look at you getting fancy using everything we learned today.
I think input is a good name for that variable, actually.
Ooh, I'm throwing in something fancy right there.
Return.
Yeah, you are.
Yes. The Visual Studio IntelliSense is really throwing me off. Basic, what am I doing?
And don't worry, guys, I'll have him scroll his text size down just a tad in just a second.
Okay.
So go ahead and change your...
Do you want up or down?
go down just a little bit to try to... Not too small. We can also hide away some of the toolbars up at the top to give ourselves some more real estate space. There you go. And then you can bring the size back up.
Actually,
Hunting for the hotkey.
There we go.
Nice. All right, good deal. Perfect. All right, so what I'm going to do before any questions start coming in is I'm going to hit pause and give everybody a few minutes to get this all typed out, just so that we, again, conserve on video time. So pausing, resuming recording. All right. So it looks like, all right, outstanding. We actually have everybody having got it. That's fantastic. So Nelson, if you don't mind, go ahead and start up at the top and walk everybody through this after you demonstrate it.
First, I want to run it and, well, make sure that there's no bugs. Okay, let's see if I can get all of them right this time. Did I seriously forget somebody?
Nelson.
What?
Nelson.
Oh, no. Ooh. Oh, okay, I'm bad at this.
Just for the record, Meta's behind me screaming, "You forgot Applejack!"
Oh, well, she's like the least characterized person in the show. So.
Anyway.
So now you see that the program does properly execute. And so if walking through this method line by line, we start off with console.writeLine, just prompting the user to enter a number. we declare a variable, but we don't assign it to anything because we're going to be using it later. Then we have a string input equals console.readline. So we store the input of the console into a string. Then we do the TryParse, and we introduced the TryParse today, but basically what's going on is this is executing first, and it's attempting to parse this input string into a number. If it is successful, it will return true, and number of names will be set to the value that it was parsed out. If it is not successful, it will return false. Because we want to catch the condition in the case that it's not successful, line 2 is irrelevant. That was when I wrote out the stuff earlier, it popped up because some of the stuff I was using was in a different namespace, but you don't need line 2 at all. So then we have int.tryparse. It's going to go ahead, and if it's not successful, it's going to return false, and we negate that so that if it's not successful, this expression is true, so that this if statement executes. And if this if statement executes, the first thing we do is say that input was not a number. We inform the user that they are incapable of following basic instructions. We halt the execution of the program to wait for the user to enter a key, and then we return. And we will be getting into what return means and what it does and what you can do with it later. But for right now, if you see that return keyword followed by a semicolon inside of the main method, that means terminate execution of the program immediately. So no code is going to execute after this return statement. Okay, so now we have a console.writeLine that instructs us to enter a specified number of names. The number of names was the result that we parsed out from using the int.tryparse method. Then we create an array of strings called names, and we give it a size of the number of names that was entered previously. So now we have a new array that can contain up to X amount of items, where X is what we typed in earlier. Now that that input has been verified as a number, we can use it as a number, as an integer, and specify to the array that that's the amount of items we want to be able to store in this array. Following that, we declare and initialize a new variable called nameCounter. We're going to be using nameCounter to keep track of what item in the array we're currently positioned at. Then we open up in a while loop. This while loop says, while nameCounter is smaller than number of names, continue execution. So if number of names is 1, the first thing that's going to happen is it's going to say, is 0 smaller than 1? If 0 is smaller than 1, then execute. And 0 is smaller than 1, so this while loop will be entered. Once the while loop is entered, it prompts us for a particular name at a specific index. Following that, it will ask the user to input or to enter text, so it'll halt execution on this line. And then once the user has hit enter, the result of whatever they typed into that line will be stored into the names array. Now this is the important part. It'll be stored into the names array at the index that nameCounter points to. The first iteration of this loop, nameCounter will be 0. The second iteration, nameCounter will be 1, 2, 3, 4, and 5, and so on up until nameCounter is equal to number of names. Once nameCounter is equal to the number of names, the while loop terminates. We increment nameCounter by doing this right here. NameCounter equals nameCounter plus 1. Now remember, if number of names is 5, we want to go between 0 and 4. So that's why everything is crafted the way it is. We increment the number after we perform the indexing operation, and we check to make sure that nameCounter does not equal number of names, nor is nameCounter greater than number of names. So if nameCounter becomes 5 and number of names is 5, this while loop will terminate because that condition is no longer true. And that's important because we cannot access the 5th index of an array if it's only a 5-element array. Because remember, arrays are 0 indexed. The last element of a 5-element array is going to be at index number 4. So continuing on, we do the same pattern right here where we initialize nameCounter to 0 again. We perform the same computation inside of the while loop's condition. We retrieve the name at the specified index out of the array. So we retrieve the name at the index that nameCounter points to. Remember, this will be, assuming that number of names is 5, this will be 0, through 4 as the loop progressively increments or iterates over itself. Once we have the name aliased out into a variable, we output it, also appending on the name counter and the name. So we say name blah is blah. Finally, we increment name counter, so we move over to the next name. Of course, when this happens, the loop goes back to the condition. If we've reached the end of the array, it will quit. If we haven't reached the end of the array, it will continue to loop again, and so on and so on and so on until a number of names has been satisfied. Finally, once we're done with this, console.writeLine finished, we just tell the user that we're finished with them, and then we halt execution until the user hits a key.
Any questions? I have many, but okay, that's completely fine. He's going to watch the video later, but I want to remind you guys, we are going to make ourselves available for those of you that need any extra help or assistance with what you're coding, or if you're confused about anything. After you watch the video, this coming Wednesday, so day after tomorrow, we will be here for you guys, same time, 3 p.m. Central Time. That's our time. And if you look over in the questions panel, JT's got a question for you. Nelson.
We're using number of names. If we use names.length and cached it versus not caching it, is there a performance difference? No. We could have simply used, immediately after we initialized the array, we could have simply done names.length. Now, yes, there is actually one that is going to result in a virtual method invocation, which does have performance penalties in the sense of nanoseconds, or maybe even microseconds, or whatever smaller. But so I can't say that there's no performance difference, but I can say that it's absolutely worthless to think about that sort of level of optimization. Yes, even for an update loop for a game. We're talking about a single instruction. How would one go about changing the intername X to start from the number 1? Good question. The way that I would do it is I would simply I would simply do that. Now, in this case, the parentheses are going to probably be significant because now it depends on the order of operations in relation to string concatenation. But as long as you put in parentheses here and increment it once, or not increment it, but add once the value, you'll get the proper prompt.
Okay, so if there are any other questions, because we're almost to the end of today's class.
Yeah, well, as far as people who say that, they understand what's going on, but they wouldn't necessarily know how to create it themselves, that's always going to be the first step of anything you learn in programming. It's always going to be being able to read code first, and then being able to identify patterns in which the tools you've learned would shorten your code or make it able to do things that were previously impossible. At this point, it's just a matter of repetition and using loops to solve problems as best you can, and it'll get easier.
I really think it is just like learning another spoken language, like learning French or German or whatever. It's the same thing. It's got its own grammar and syntax, and you kind of need to know a base amount of that, and then you know enough to learn
like the idioms.
Sort of why one way is better than another. Yeah, exactly. You learn the slang and the idioms and so forth. Actually, Miranda, no, I'm not. I was.
And now you're like tiny.
Actually, yeah, it's getting silly.
Steve, the question in that particular case was on a personal nature in regards to his...
She just said, Gav, are you really fat? With my username being Fat Gav. And no, I'm about 9 stone. So there you are.
Yeah, we're working on a solution for instances where BuzzNet might be blocked by firewalls or unable to run on your operating system. So yeah, so
let's go ahead and talk
a
little bit about the homework.
Sure. So the homework is to write a basic bubble sort. And the bubble sort algorithm is very straightforward, and it's a way to sort an array of items. And the idea is that start off with an array of, let's say, integers provided by the user. Do you want a variable length or do you want a fixed length, Jason?
No, let it be variable. I mean, they've learned how to do that now. So it could start out by the program could say, so how many numbers would you like to sort today?
Yep. And then sort all of the items in the array by descending value. Oh, man, that's not how you spell that word. I know it's not. I know it's not. Google knows how it's spelled, though. Okay, so then after that, print out the sorted array to the user. So example output may be how many items or how many numbers do you wish to sort? Followed by, let's say, 4. And then it would say enter number 1. And then we can say, I don't know, 43, 2, 3, 4. And this one can be that. And then sorted output will be, in this case, it'll be, sorry, wow. So something like that. And remember, these symbols are not required in your output. It actually does look nicer if you do, but the reason I use them with the example outputs is to denote that this is something that the user typed in. So is everybody good with what, because I do want to talk about the bubble sort algorithm for a second, but does everybody sort of understand the base framework, I guess you could say, of this program, or at least how the output and input is structured? Alrighty, so the bubble sort algorithm, basically what you need to do with the bubble sort algorithm is you need to loop through every item in the array. And then you need to make one decision. And that decision is going to be, is the number that we're currently sitting on larger or smaller than the number that is either above or below the stuff in the array? So we might start off with, in this case, we might start off with an array looking like this, 43, 2, 3, 2, 3, 5, 4, and 209. And then after the first iteration of the loop, we might have something like this: 2, 3, 5, 4, 3, 4, 209. And then the third iteration of the loop, we might have 2, 3, 5, 4, 3, 209, 4. And then 2, 3, 5, 209, 4, 3, 4. So hopefully you can kind of see the process that we're going through. We're starting off with a completely unsorted array. The first iteration, we decide that 2, 3, 5 is larger than 4, 3, so it needs to be moved to the left. The next iteration, actually there are a few iterations in here that aren't represented because what happens is now it's going to ask, okay, so 2, 3, 5 is now at the top because it is the biggest number. Now let's go ahead and look at 43. Is 43 bigger than 2, 3, 5? No. Now let's look at 4. Is 4 bigger than 43? No. Now let's look at 209. Is 209 bigger than 4? Yes. So we move it up once. And then we ask, is 209 bigger than 43? And then we say yes, so we move it up again. And then we say, is 209 bigger than 235? And we say no, because it's not. And we're now at the end of the array. We sorted everything, and we print out the results to the user.
Hopefully you can see where the naming bubble sort came from.
Mm-hmm. Missing is 4 bigger than 43. Yeah, that happens, but when it's not bigger than 43, nothing actually happens to the list. This is simply the mutations that happen, not necessarily every iteration.
Right.
It compares from the first pair to the last pair. So first and second, first and third, or is it the other way around? I'm confused.
Well, it'll start with the first pair. Then this iteration will terminate simply because this can't be moved up any further. Then it's going to start with then it's going to go to the next pair, which is 43, 4, and then determine if anything needs to happen. In this case, nothing needs to happen, so no change is made. Then it's going to say 4 and 209, in which case, yes, these need to be swapped. And then it's going to go backwards and do 43, 209. Do those need to be swapped? And then I'll say yes, and you'll end up with this result.
There's a very easy way where you're just always going forward with your loop. So it's going to look at 0 and 1, swap if need be. 1 and 2, swap if need be. 2 and 3, swap if need be. 3 and 4, swap if need be.
Yeah.
That and then here's the ultimate thing.
Sense.
If you were able to walk through from 0 all the way to the end of the array without swapping anything, then they must be sorted.
Yeah.
Man, I just gave an easy approach answer away. Silly me. Raymond, he's actually rearranging the array. The question was, are you rearranging the array or just the output? And
yeah, I'm actually going to be mutating the array
he's
itself.
actually rearranging the array.
So array index 1 ends up being 209.
Yes.
Cool.
And I want you guys to give this a shot. Those of you that are completely new to working with code, remember, we will be here again on Wednesday, and I'm sure even if you can't make it, somebody will that's going to say, what? I still don't understand what's going on, but I've been trying. But I want to see how you've been trying. That's going to be the important thing on Wednesday. So we have something to talk about instead of just outright giving an answer, because we don't want to do that.
in all seriousness, with when you're learning these things for the first time, it's well worth getting out 4 pieces of paper and shuffling them and laying them out on the table and working out how would you physically go about sorting these out one pair at a time.
Yeah, how would you come up
literally
with
do it,
repeatable...
but literally do it with bits of paper with numbers written on them, and look at what you're doing, what order you're doing things in.
Yeah, and try to come up with
then replicate that in the code.
Yeah, but it's important to come up with, not use your intuition at all, but use a repeatable system that you perform over and over and over again on those pieces of paper. That's relatively the same operation over and over again. Because obviously humans can intuitively sort things, but computers cannot.
Sorry, Darth Greg was awesome. I'm off to Office Depot for a pallet of paper.
You need to write smaller, definitely.
Thank you for the good laugh for today. That was awesome.
Yes, the bubble sort is part of the homework, Wolf Nightly.
It is the homework.
Unless you want to implement a different sorting algorithm.
Oh, there's some beautiful ones out there.
No bubble, just one.
Yep,
just one. We don't want to kill Gavin.
I'm not making that mistake again.
Yeah, just the bubble sort. It is very easy. The beautiful thing about this assignment is it's your first real exercise in logical thinking, because it's not a huge program. As a matter of fact, this program is going to be smaller code-wise than the homework that you turned in last week. True story. Now Dunn's going, logic? All right, that's it. I give up. No, come on. It's not that bad. It just requires a little bit of thinking.
Segfault,
yeah,
no.
do
because Link actually has a method in there that'll do this sort
exactly.
of thing. That's cheating.
No cheating. Actually write out the logic.
Actually, interesting, because I mentioned this with the Thursday class as regards to the specificity of the homework. And I actually had comments along with a couple of the homeworks for Thursday that from people surprised to find that they actually stumbled on doing it with just ifs and elses and really had to think twice about it, just because their natural instinct was to reach for more complex or more advanced ways of doing it. I think part of doing it with just the things that you've been taught so far is it makes you actually analyze the problem possibly in a way that you hadn't before now.
Yeah.
So I know this is going to seem extremely difficult to some of you, but please try it. Once you start kind of getting a feel for what's going on, it's not bad. I mean, it really is not bad. This is really about logical thinking more than it is anything else.
Yeah, like what Segfault said, if you can solve this, you'll feel great.
You will, absolutely. And Musaru asked the incrementer and decrementer operators with plus, plus, and minus, minus. Yes, you can use those if you'd like.
We just have a kind of off-topic question about Resharper.
Oh, okay. What's that?
Can you guys go over what Resharper does, or is that a tool you should use later on? Well, Resharper is a plugin into Visual Studio that provides a bunch of functionality. But the thing about Resharper is, Gav likes to point out, and I totally agree with him, that it shows you better ways to write code constantly. But if you don't even know the simple way to write the code in the first place, then it's rather than helping you, it's going to be very distracting.
I would say it's more of a 201 tool. Once you reach the point where Link isn't completely terrifying to look at, it can be very handy at that point in teaching you the sort of the nooks and crannies of classes like the Link classes, where there's a lot available to you that you might not instinctively try to use because you just don't know it's there. And at that point, Resharper will stick his hand up and wave and say, hey, did you know you could use this? So it's more of an intermediate learning tool.
Did we go over LINQ during week 1? Yes. Generics, generic type inference. We wrote a few programs in IL. The answer is no. LINQ's something that we're definitely not even going to be covering in this course.
Yeah, for sure.
The intro course. But yeah, as far as Resharper though, and it does a bunch of other stuff. It makes writing code a lot faster with the shortcuts and code generation. But again, if you don't, it's one of those things where you have to know ahead of time, what exactly am I going to do? Or what exactly do I need to do before you can really instruct a tool to do it for you? So, yeah.
And as Darthray pointed out, it's not free.
It's not free, but it's worth every penny.
I would genuinely say if you know up front that you're not going to be able to afford to buy it, don't try it. It's that good. You'll get to the end of your trial and it'll say this doesn't work anymore, and you will cry.
Where did C# get its name? C. And then they added a sharp to it. C's an old programming language that C# takes a lot of hints from as far as the syntax goes. Then I guess the sharp is just something that they do, like F#.
I think we're about to go ahead and start wrapping this up now. So you guys have what the homework assignment is. You know that we'll be back here this coming Wednesday, making ourselves available once again. And just for toots out there, we will make sure that we are recording it as well. So for those of you that are not able to make it to that session, no worries. You'll have access to the video. Like I said last time, things were going to start feeling a little bit heavier this time around, and then it's going to continue to grow. But an interesting thing will begin to happen. For those of you that are truly new to this stuff, you will start becoming comfortable with logical thinking, with programming. And that's when we get to have a lot of fun.
Don't forget to check the homework submission guidelines thread that is now stickied in the Member Sponsor Lounge to see how to submit it, bearing in mind that you're submitting it to Zach's email, and he will ignore anything that doesn't fulfill the submission guidelines because he has about 8 million emails to wade through each day. I was asked to point that out specially.
So, yeah, it's a great class. I hope you guys are enjoying it. I know that you're going to, I know a lot of you are going to need to go and review the video again. That's to be expected, and don't let that stress you out. And if you have questions when we meet back up on Wednesday, ask them. Don't be shy. So anything else you want to add, Nelson, before we bring this to a close?
No, I think that's good.
Okay, well, I hope you guys had a good time. And if we don't see you on Wednesday or Thursday night, then we will see you in class next Monday. So you guys all take care, and that wraps up today's class. Thanks a lot, guys. Bye, everyone.
See ya.